You know that feeling when you've spent way more time scrolling through Netflix trying to find a movie than actually watching one? Or maybe you've sat at a restaurant just staring at this massive menu, completely paralyzed because, well, the burger and the pizza look exactly equally good. We've all been there. Well, welcome to This Explainer. Today, we're going to unpack a centuries-old thought experiment that takes that everyday feeling of total indecision and literally pushes it to the absolute limit. It fundamentally challenges how we think about decision-making, logic, and honestly, even our own minds. We're looking at the famous, or maybe infamous, paradox known as Buridan's ass. So, what happens when perfect logic leads to certain doom? I mean, it sounds like a complete contradiction, right? From a very young age, we're taught that being rational, calculating the pros and cons, and using cold, hard logic, that's the absolute best way to survive and thrive. We build entire economic and behavioral models around this idea of the rational actor. But this Socratic puzzle we're about to explore, it turns that entire concept completely upside down. It exposes this terrifying glitch in the matrix of pure reason. Okay, let's dive into this and see exactly how high the stakes can get when logic is taken to its absolute unforgiving extreme. Section 1. Meet the rational donkey. A perfect choice. All right, I want you to visualize the protagonist of our thought experiment. Imagine a perfectly rational donkey. Now, this isn't your average stubborn farm animal just munching on grass. No, this is a creature of pure, unadulterated logic. Think of this donkey like a supercomputer with hooves, right? A being that absolutely refuses to take a single step without a mathematically sound, completely justifiable reason for doing so. Every single choice has to be fully optimized. So, we take this impeccably logical beast and we place it exactly in the middle of two identical bales of hay. The setup is incredibly precise. The donkey is equally hungry for both bales, and both bales are perfectly equal in every single conceivable way. They're the exact same size, the exact same distance away, the exact same freshness, the whole shebang. Over on the left, we've got bale of hay A. On the right, bale of hay B. They're equally desirable, and they're equally accessible. There is absolutely zero logical advantage to picking the bale on the left over the bale on the right, or vice versa. If our donkey calculates the utility of bale A, let's say it gets a score of 10. If it calculates the utility of bale B, it also gets a score of 10. And according to the foundational premise of this scenario, because our donkey is a perfectly rational agent, it strictly requires a reason, a solid logical basis to have a preference. It can't just flip a coin in its head. But the math here? It's an absolute perfect tie. Section 2. The paradox of paralysis. Let's watch perfect reasoning spiral into fatal inaction. Now watch how this builds, step by step, into this totally inescapable trap. Step 1. The donkey must act on a rational preference. It can't just guess. It needs a definitive, measurable reason. Step 2. Well, as we just established, no rational preference exists because the bales are perfectly identical. Step 3. Therefore, the donkey cannot make a choice. It calculates, it recalculates, but the equation always balances out perfectly. And then step 4, because it literally cannot choose which bale to eat, the donkey stands frozen in place and starves to death. So if action truly requires a rational preference, then perfect rationality leads to fatal inaction. Just think about the sheer absurdity of this contrast. The donkey is so incredibly mathematically logical that it starves to death while standing exactly halfway between an all-you-can-eat buffet. It's completely paralyzed by its own perfect intellect. It is literally the ultimate case of analysis paralysis, just taken to a deadly extreme. The very tool that's supposed to ensure its survival, its flawless reason, is the exact mechanism that destroys it. Crazy, right? Section 3. The free will twist. Against determinism. Because here is where the story completely changes. This paradox is named after the 14th century French philosopher Jean Buridan. But here is the plot twist. Buridan wasn't a zoologist. He wasn't actually talking about animal behavior at all. And he definitely wasn't trying to write some absurd fable about livestock. Buridan actually used similar scenarios to argue against determinism in human free will. This famous puzzle, it was always meant to be a really profound metaphor for the human mind and how we navigate the complex choices in the world around us. Buridan was posing this massive challenge to determinism, which is the philosophical idea that every human action is strictly determined by a preceding cause, or a specific measurable preference. He asked a really fascinating question. Does perfect rationality force a human to choose arbitrarily or paralyze them completely? If we're placed in a situation with two perfectly equal options, and our actions are purely dictated by deterministic preference, we should be paralyzed, just like that tragic donkey. But let's bring this into reality for a second. We know that if you walk into a grocery store and you're staring at two identical cans of tomato soup, perfectly aligned on the shelf, you don't freeze in the aisle and starve to death. You don't stand there for 3 days calculating the microscopic dust particles on one can versus the other. Eventually, you just reach out, grab one, and toss it in your cart without a second thought. Buridan suggested that this mundane, everyday action is actually incredibly profound. It proves that humans possess a distinct form of freedom, a capacity to spontaneously break the tie that goes way beyond pure calculated, deterministic reason. We can act even when logic gives us absolutely zero direction. Section 4. Escaping the logical trap. Resolving the paradox. Let's see how modern thinkers actually dismantled this philosophical deadlock. Today, this paradox is generally viewed not as some unsolvable problem, but as a scenario that brilliantly highlights the flaws in its own initial assumptions. We don't have to accept the donkey's fate. Actually, we have 3 primary escape routes. First, perfect equality is practically impossible. Second, practical rationality actually allows for arbitrary choice. And third, animals simply aren't purely rational in the way philosophers like to pretend they are. Let's break these down one by one to see exactly how we escape the trap. First up, the concept of asymmetry in reality. See, this whole thought experiment relies on a mathematically perfect vacuum, a completely isolated theoretical space. But in the real world, nothing is ever perfectly equal. Real life is wonderfully messy. Slight environmental shifts or completely random neural fluctuations will immediately break any theoretical tie. Think about our donkey. Maybe one bale of hay suddenly smells just a fraction of a percent fresher because a tiny breeze picked up. Maybe the wind blows a millimeter in one direction, causing the donkey to subconsciously shift its weight to its left hoof, making the left bale infinitesimally easier to reach. Even a completely random misfiring of a single neuron in the brain's decision-making cortex would instantly destroy the perfect symmetry of the situation. Real-world decisions simply never happen under conditions of absolute perfect mathematical equivalence. The universe is just inherently asymmetrical. Next, we've got to quickly address the donkey in the room: animal instinct. Real animals operate on habit and immediate environmental cues. They aren't rigid philosophical constructs endlessly running logical algorithms in their heads. A real donkey isn't out there calculating utility scores. It relies on deep-seated evolutionary instinct. And that instinct is hardwired for survival, which would instantly override any perceived logical deadlock, long before starvation ever became a microscopic possibility. If a real donkey sees 2 bales of hay, it just walks toward one and starts eating. End of story. Section 5. The practical takeaway. Arbitrary choice. This is where we apply this 14th century puzzle to our own modern decision-making. Just look at the stark contrast here. On one side, theoretical rationality demands that we wait for a definitive logical preference. In our extreme scenarios, sticking rigidly to this theoretical purity guarantees starvation. It's a total failure. But on the other side, we have practical rationality. This is the understanding that making an arbitrary choice, literally just picking something for no strictly logical reason at all, guarantees survival. A truly rational agent, living in the messy real world, recognizes that the consequence of not choosing is actually the worst possible outcome. It's the realization that endless deliberation has a really devastating cost of its own. So the absolutely crucial takeaway is this: when logic offers no preference among good options, an arbitrary choice becomes the most rational action. Think about that for a second. Sometimes being truly rational means realizing that pure logic has hit a brick wall. In those moments, abandoning theoretical logic just to make a random arbitrary choice to avoid a bad outcome is, paradoxically, the smartest and most logical thing you can do. So the next time you're stuck overthinking a minor decision at work, agonizing over 2 equally good marketing strategies or 2 virtually identical software solutions, remember the donkey. If both options are genuinely good, the only truly irrational move is to freeze and do nothing. The cost of endless deliberation is much, much higher than the cost of just picking one path and moving forward. I want to leave you with this final, really provocative thought. Is the ability to make an arbitrary choice the ultimate proof of human free will? If we aren't completely bound by mathematical preferences, if we can look at 2 perfectly identical paths and simply say, I'm going left just because, does that arbitrary spark prove that we're more than just biological computers? Do we have a ghost in the machine that allows us to break the ties of a deterministic universe? It's a super fascinating question to ponder the next time you find yourself stuck trying to make a perfectly logical decision. Sometimes, you just need to pick a bale of hay.